Welcome to Physics with Mr. Brazil. I'm going to show you a pulley problem with a hanging mass and friction. Pulley, frictionless, massless. If we have friction about where the pulley turns, we have to take that into account. And the pulley's mass has inertia. That also affects the pulley system. So massless and frictionless for the pulley. What is the acceleration of the pulley system when the coefficient of friction is 0.15 and the mass is 7 kilograms, is pushed left. So that surface has a friction force. And the hanging mass is just hanging, so no air friction. So let's find out this acceleration going to the left. Now, I tell my students to put their coordinate plane like this, x, y, and y-axis here, and x. So this way we can straighten out this chord. Let me show you what that all means. That means that the friction force is going to be going on the 7th kilogram mass is going to go to the right because it opposes motion, because this system is going to be moving to the left. Okay. We have the pulley, so we have a tension here, and we have this other tension from the hanging mass, so that'll be negative, and then the 13 kilograms is, I'm going to call it FG13. So this whole system is moving to the left. So this is a negative M total, okay, and times the acceleration. So in this case, we're just trying to find the acceleration for this system. So let's give that a try. First of all, since I made this the x-axis by unbending at the pulley, this will be friction is moving in the positive direction. The weight of the 13 kilograms is also in a positive direction, but the whole system is moving in the negative direction, and total A. So the acceleration for this system is going to be the friction force plus the gravity of the 13, or weight of the 13 kilograms, divided by the mass total. Okay, so we're going to have mu m7 times g plus the mass of the 13 kilograms times g all over the total mass of m7 plus the m13. All right, so let's put our values in. See, I got plenty of room here. So 0.15 times 7 let's fix that up. 7.0 kilograms. And I'm going to factor out G plus the 13 kilograms and times 9.80 meters per second squared, all over negative 20, I'm going to put a dot for 2 sig figs, kilograms. Okay, so far seems to make sense, right? Now, we're going to have a negative 6.9 meters per second squared. Well, the object is going to decelerate because it's moving to the left. It got pushed. Okay, so this will be our acceleration. All right, now what is the tension on the cord? So tension on the cord. Well, there's two approaches here. and this will kind of make sense. Okay, so if we take the pulley and cut it in half, I have it in blue, I cut the pulley in half, well, I do have the tension on the 13th mass going upward and, and the gravitational or gravity pulling on the mass going downward. This is just a classic y x-axis. So this sum in the y direction is going to equal T minus the force of gravity on 13. Okay, now this system is moving upward. So this is going to be a positive direction, m13, the mass of 13, but the acceleration is a deceleration, it's a deceleration. So we're going to have a as a negative number. And remember, this negative is not going to cancel out that other negative above. I'm just trying to set up the system. So here's what's going to happen. This is going to be T equals, I'm going to factor out the 13 times G minus the A. The A is already negative up above. So 13 kilograms times 9.8 meters per second squared minus the 6.9 meters per second squared. That's going to give us 38 2 sig figs newtons. Now, some folks were trying to figure out also what happens to the mass up top. Well, I'm going to make that a different color, and let's do that. And in this case, the 7 is going to the left, the 7 kilograms. So this is going to be in the x direction because it's on that flat portion of the pulley system. We're going to have tension, T. We're going to have the friction, okay? It's also in a positive direction, okay? But it's moving to the left, so the whole system is a negative. And this is going to be for the 7, but it is a deceleration, so A is negative. So in this case, it is a positive force due to the 13 kilograms hanging that's pushing to the right. So in this case, it's going to look like this. And again, I'm going to factor out the 7. But we're going to have the mass of 7 times a positive A, but minus a negative G, okay? And 7 kilograms, and this is going to be 6.9 meters per second squared minus 9.80 meters per second squared. Oh, what's missing? Friction. So I totally missed that completely. So let's erase all this and let's set that up. See, skipping steps, not a good thing. So don't skip steps. So this is going to, let's do it. All right, so this is going to be mass of 7 times A minus mu m7g. True, we're going to factor out 7, but A minus mu times g. That's going to give us a totally different answer than the one I was going on, okay? 7.0 kilograms times 6.9 meters per second squared minus 0.15 times 9.80 meters per second squared. And this also is equal to 38 newtons, which is true. The pulley on both ends, the horizontal and the vertical, the cord will be 38 newtons. Okay, so this is how you solve this. You need to understand that if the system is going to the left, that the total mass times the acceleration is a negative direction, but a deceleration is always a negative acceleration. All right? If you need to review this, review it. Okay? Keep practicing physics. Bye.